Okay, so today we're going to talk about homeostasis and then stimulus and response. And we've got my guy right here on the high wire, and he's trying to maintain balance. He's trying to maintain balance. That's all about homeostasis, is keeping things level, keeping things balanced within the body, okay, within the body. All right, you guys are following along. There's spaces on your notes that you need to fill in as we go. Okay, so first let's look at the definition of homeostasis. Homeostasis is the term we use to describe the constant state of internal environment. Constant state of internal environment. Now, you've seen this word constant before. Right there, constant. We've talked about constant when we talked about experimental design, the old if-could-if chart. Somebody tell me, what is a constant with regards to experimental design? What is a constant? A constant is something that stays the same. So homeostasis is about maintaining balance, and it's all about staying the same. Okay, so right here it says that homeostasis is a state of balance. State of balance within the body. Okay, keeping things the same within the body. These two words go together. Okay, balance and constant. They go together, keeping things balanced in the body. Okay? Now, your body's always trying to keep things balanced. Every part of the day, your body is trying to maintain balance. Water, for example. If you don't have enough water in your body signals you that you need more water. How does your body signal you that you need more water? Okay, how do you get signaled that you need more water? You get like a dry mouth, okay, and you get that feeling that you are thirsty. So in response to that stimulus, in response to that internal stimulus of being thirsty, you go get a drink, and you add water to your body. Okay, because you're trying to keep that water level in your body the same. Now, what happens when you have too much water in your body? No, you don't necessarily throw up. You have to get rid of that extra water. How do we usually get rid of excess water in the body? You go to, there's lots of different ways we can phrase this, but you go to the restroom and you go to the bathroom and you get rid of that excess water, because you don't want too much water, just like you don't want too little water. You want to maintain the same amount of water. Same thing goes with, listen, same thing goes with having the amount of food or energy in your body. If you don't have enough food or energy in your body, you get run down, okay? You feel hungry. That's your stimulus that's coming from inside of you. That's an internal stimulus. Therefore, you respond by going and eating and getting more food, okay? And then increasing your energy levels, okay? So it's all about maintaining this constant state, keeping things level and balanced within the body, okay? Keeping things balanced. All right. So here it talks about the body as being a thermostat. So here's a word, thermostat. Thermostat. Somebody tell me, what is a thermostat? What is a thermostat? Max, what is a thermostat? Something that measures the temperature. It does measure temperature, but it's not its only job. What else does it do? It changes the temperature in your house. It displays the temperature in your house. That's all true. Okay. Your temperature thermostat is this little box in the wall in your house. Everybody's got a thermostat in your house. It's usually in the hall. Okay, it's usually in a central location. Sometimes some houses may have two thermostats, one for upstairs or downstairs and so forth. But you've got these two thermostats, or this thermostat in your house, and it monitors the temperature. Now, listen. You set the temperature in your house what you want it to be. Let's say you set the temperature at 74 degrees. You want the temperature in your house to be 74 degrees. That's a nice, comfortable temperature for you. Okay? So in the house, you set your temperature at 740 degrees, but let's say it's 110 degrees outside. It's hot outside. That heat from the outside is radiating in. It's coming through the windows. It heats up your house. So the temperature inside your house goes from 74, 75, 76, and all of a sudden that little box, that little thermostat on the wall goes, whoa, something's wrong here. It's getting too hot. So what does that thermostat do? How does it lower the temperature? It turns on the air conditioner to blow out cool air. Now, the thermostat and the air conditioner are actually separate of each other. The air conditioner isn't very smart. All the air conditioner knows how to do is blow cold air. It doesn't know how hard to blow cold air. It doesn't know at what temperature. It just blows cold air, period. The little box on the wall, the thermostat, turns on the air conditioner. The air conditioner blows that cold air into your house. Temperature goes from 77, 76, 75, back down to 74. Now, what happens when the temperature gets back down to 74? Does the air conditioner continue to blow cold air? It turns off. It shuts off. Okay? It goes back to that 74 number where it's set at. Now, it's still hot outside. So we're nice and comfortable at 74. The air conditioner is off. However, that heat is still radiating inside. It starts to heat back up. We got 74, 75, 76, 77. All of a sudden, you got that thermostat on the wall. It's going, whoa, getting too hot again. What do I better do? Turn on the air conditioner. The air conditioner comes on. It cools things off. It goes back from 77 down to 76, 75, 74. And we get to 74 and it shuts off again. It's that constant cycle. It's that constant cycle of turning the air conditioner on and off in order to maintain that 74-degree balance. That's the goal. And it works the same with the heater. I mean, if the temperature is going down, it's during the wintertime and it gets cold and it goes from 74, 73, 72. So the air conditioner comes on, the heater comes on. But it's trying to maintain that balance. Now, guess what? Your body is the same way. Okay? Now, we initially try to help our body out. If we have this sensation that we're too hot. We have this sensation that we're too hot. Okay? We can start by voluntarily taking off some clothes. Maybe we have a jacket on, we got a sweatshirt on, we take that off and try to cool off. We're hot. On the flip side of that, if we're too cold, we add clothes because we're trying to maintain this temperature. Now, here's the deal. You guys are warm-blooded animals, therefore your body temperature always stays the same. Your body temperature stays at 98.6 degrees Fahrenheit, 37 degrees Celsius. It's always trying to stay the same. Now, because you're warm-blooded and because your temperature stays the same, your body has to maintain that temperature. It's vital, absolutely important, necessary that your body temperature stay at that constant temperature. Because if your body temperature doesn't stay at 98.6, then all of a sudden things start to happen that are not so good. Does that make sense? Okay, so you first start off by trying to regulate the temperature yourself. However, if you can't regulate the temperature yourself, okay, your body is going to take over. Okay, your body is going to start to take over. So when your body gets too hot, okay, the brain starts to do something on its own. What does your brain tell your body to do when it's too hot? It tells your body to sweat. Your sweat is your own personal air conditioning system. Okay? You sweat, and it's actually called evaporative cooling. When you sweat, the sweat comes out of your pores on your skin. As the sweat evaporates from your skin, it actually cools your body off. It's your body's own personal air conditioner. Because your body's trying to maintain that 98.6 degree Fahrenheit temperature. So when your brain senses that you're getting too hot, it turns on the sweat glands. Sweat starts flowing. You cool off. Now here's that thermostat. Here's that thermostat. You sweat, right? And you cool back down to where you're supposed to be. Once you're cooled back to where you want to be, that you're comfortable, do you continue to sweat? Does that air conditioner continue to stay on? What does the air conditioner do? What do the sweat glands do? They turn off. Okay? If you were sitting there and you were nice and comfortable in this room and you were pouring sweat right now, I'd be worried about you. If you were all right now sitting in this room pouring sweat, I'd be concerned because that means something's wrong, right? Your brain is obviously, something's messed up there because you're not hot and you're sweating, okay? On the flip side of that, when you get too cold, right here, when you get too cold, the brain also has a process for that as well because you don't want your body temperature to drop down too low. When you get too cold, you start to shiver. You start to shake. By shaking, you generate body heat to warm your body back up. Also, you get these little bumps on your skin. What do you call those little bumps? Goosebumps. Goosebumps actually make the hairs on your arms stand up. And when those hairs on your arms stand up, they actually trap in warm air closer to your body to help keep your body warm. So your body's going through all these actions to maintain that body temperature. Keeping that body temperature balanced. That's homeostasis. So, here are the actions that we have that the body takes. Here are the actions that we have when the body takes as a thermostat. Again, the body taking these actions to maintain temperature as a thermostat. Okay? When your temperature gets either too low, okay, or too high. So if our body temperature gets too low, okay, we get cold. Obviously, we're not going to sweat if we're too cold, are we? No. Again, I'd be worried about you if you were sweating when you were too cold. Okay? But your muscles are going to contract and less heat is carried from the core of your body where it's nice and warm to the surface. Your blood vessels in your arms actually start to move away from the skin a little bit because your skin's cold. So let's move those blood vessels, those blood pathways down lower to keep our blood warm. We don't want our blood getting hot, okay? Or getting cold. Also, as we already said, down here, okay, you're going to raise the hairs on your arm, trapping in heat, and then you're also going to shiver to generate body heat. Those are all actions the body takes to maintain that 98.6. If you're too hot, okay, your temperature is too high, the muscles are going to do the exact opposite. They're going to allow the blood vessels to move closer to the surface, okay? You're going to allow the blood vessels to cool, let blood to try to cool off, okay? You're going to sweat. You're going to sweat, and obviously you're not going to shiver if you're hot, okay? So here we have a little diagram, and this is commonly called a feedback loop because you're getting some sort of outside reading, okay, and your brain's reacting upon that outside reading. So here I've got a temperature reading, okay, and then that temperature reading coming from your skin. Your skin says, hey, it's too hot or it's too cold, and that signal gets sent to your brain, and your brain interprets that signal. It says, okay, it's too hot, it's too cold. What do I do? And I'm going to either adjust the blood vessels or I'm going to start to sweat, okay, or I'm going to start to shiver, and then that's going to go back to my skin. My skin's going to say, okay, this is working or it's not working. We need to do more. And it's this constant loop of feedback and information of your brain going back into, okay, the different receptors in your body like your nerves, okay, trying to adjust to maintain that balance we call what? What do we call that balance? Shout it out. Shout it out. Balance is homeostasis. Okay. Now, some interesting things about this. Stimulus and response are directly involved in this homeostasis process. Okay? So stimulus is something that is going to cause a response. So a room that is too hot is something that's going to cause a response. Okay, that's a stimulus. Your body's reaction to that response, okay, is the sweat. Okay? So your body's constantly taking in information, okay, being stimulated and responding to that information. Things that you don't even control. You don't even have any control over these things. For example, if you run, okay, if you run down the hallway, you run all the way down the hallway, you get to the end of that hallway, and right now that hallway looks about 100 yards long. So you get to the other end of the hallway, you run all the way down to the front office, you get to the end, okay, you're breathing hard. Okay, you're huffing and puffing a little bit, and your heart's beating. Okay? You had no control over your respiratory rate, how fast you were breathing. You have no control of your heart. Your body is responding to an exercise stimulus. When you start exercising like that, you start burning more energy, using more energy. You also need more oxygen. You're also trying to get rid of more carbon dioxide. Your body knows that. So it increases your respiratory rate. You start breathing faster to take in more oxygen to compensate. You start breathing faster to get rid of the excess carbon dioxide, the waste product. Your heart is beating faster to deliver all those things to the cells. You didn't have any control over that. It did it on its own. But again, it's trying to maintain that balance. Okay? Now, there are some cases that your body temperature gets too high. Okay? We commonly call a body temperature that is above 98.6 a fever. Fever. Now, fevers usually occur on purpose by the body. The body does it on purpose. Okay? You get an infection. An infection could be bacteria. Okay? It could be a virus. You get an infection or a virus inside your body. Those little infections, those little viruses, they like your body at 98.6. That's a nice, comfy temperature for them. They're happy. Okay? Your body says, I don't want you critters inside of me. I'm going to get you out. So how does your body get those critters out or kill those critters? Turns up the temperature. Okay? Sets it on fire. Turns up the temperature. So your temperature goes from 98.6 to 99 to 100 to 101. Those little critters can't survive at those higher temperatures, so they die. So a fever is actually, when you get sick and you have a fever, it's actually a good thing. Most doctors will tell you that if you have a mild fever like that, a mild being 99, 100, 101, they tell you don't do anything about it. Keep the fever. It's your body's way of fighting off the infection. Now, there are some times that I will say that your body gets a little carried away, starts going in overdrive, and your fever continues to get up to 103, 104, 105. You get to 106 or 107, you're dead. Okay? Yeah. So again, your body temperature can't get up that high. You got to maintain homeostasis to some degree, because if your body temperature gets up too high, it'll ultimately kill you. Okay? So sometimes when your body goes overboard and you get to 105, sometimes you have to make a hospital visit. And we got to take things in our own hands, get your body temperature back down to a safe temperature. Okay? I don't know if anybody's ever had that occur to them or a family member that has had to go to the hospital for an overly high fever. Usually it doesn't happen so much, more like Tylenol and Motrin and different over-the-counter medicines like that. A lot of times will help reduce fevers when they start getting too high. But occasionally, sometimes you have to go to the hospital because it's just out of control, and that's not a safe situation when your temperature gets that high. But it's your body's response to a stimulus. Now, this bacteria, this infection that's inside of you, is that internal or external? Internal or external? It's internal, right? It's an internal stimulus, correct? That infection is internal. That infection is inside of you. Therefore, it's an internal stimulus, and your body responds by causing a fever. Now, here's another little stimulus response situation. We call this one fight or flight. Okay, you're confronted with a very scary situation. In this situation, I got a grizzly bear. Okay, you're on a narrow mountain trail with this grizzly bear, and he's in your face. Okay, I'm sure you've never faced a grizzly bear before, but it's probably will scare you to death. At the zoo would be a different story because he's behind bars at that point. So you got this bear, and it could be any situation you faced. You could have gone through a haunted house. If you're scared, your body automatically, and you don't have to tell it to do so, is going to respond to that scary stimuli. Now, if you're scared, is that stimulus internal or external? What is causing you to be scared? Okay, it's the bear. It's the haunted house. Is that internal or external? That is external. It's outside of you. So that is an external stimulus, and it's causing this response. Your heart starts to beat rapidly. You start to breathe faster. You start to produce adrenaline. You're getting geared up to do something. You're either going to fight or you're going to flight. You're going to run away. Okay? If you've ever been in a scary situation, you have no control over that. Have you ever gone to a scary movie? It's your body's automatic response to that scary situation. I know, I just saw the other day there's a new horror film out. I'm sure you guys will go see it. I can't remember. Yes, that's it. If you got the boogeyman that jumps out in your face, okay. Shh. Here we go. Now, here are some other examples of internal or external stimulus. Internal or external stimulus, and then also the response to that stimulus. So if you swallow a poison, and then it causes you to vomit or throw up. You swallow a poison, okay? You swallow a poison. Is that poison an internal stimulus or external? It's internal. You swallowed it. It's inside of you. Therefore, it must be internal. Now, if it's external, you haven't swallowed it. Therefore, do you have a response to it? No, you don't need, I mean, other than stay away. But it's going to cause you to try to get rid of it. Your body's going to say, hey, I got to get rid of it. You're going to vomit. Okay? If you're exercising, we just talked about this two seconds ago. You're exercising really, really hard, okay? And then you start to build up extra CO2, carbon dioxide in your blood from exercising. Okay? You got the excess carbon dioxide in your blood. What is the stimulus there? Is it internal or external? Internal. Their blood's inside of you, I would hope. Okay? So your response is to breathe faster to get that extra CO2 out. If you're touching a hot stove, you put your hand on the stove. You put your hand on the stove. And you jerk your hand off of the stove. What's the stimulus there? Is it internal or external? The stove is external. It's outside of you. And it burns your hand. Your response is to pull your hand away. So the stove is external, causes you to move your hand. Throwing a ball. That ball's coming straight, baseball, football coming straight towards your face. Okay, your response is to put your hands up to catch it, or at least block it. Okay? The ball. Is the ball internal or external? External. It is outside of your body. That is an external stimulus. Okay, so to summarize, listen up. To summarize, you have homeostasis. Homeostasis is that process about keeping everything in your body balanced, whether it's water levels, temperature, energy levels, okay, whatever it is. Homeostasis is that process. It's that thermostat process of keeping your body balanced. It's your body constantly taking in information and your brain interpreting that information and then adjusting, making adjustments to keep balanced, okay? And how it does that is through stimulus and response. It gets a stimulus, whether it's too hot or too cold, and it responds, turning on the sweat glands, shivering, okay? And then turning those sweat glands off when appropriate. Stop shivering when appropriate, okay? In order to maintain that balance, that homeostasis balance.